Hello everyone, I am Karthik, Assistant Professor of Mathematics, SNS College of Engineering. In this lecture video, I will explain about change of order of integration. Changing the order of integration in a double integral or triple integral involves rearranging the order in which you integrate with respect to different variables. This is particularly useful when the original order makes the integration difficult or impossible. Explanation of the need for change of order of integration. One common reason is to convert the integral into a form where the integral or region of integration becomes easier to handle. For instance, if the original order results in a complicated expression for the integrand, or if the region of integration is difficult to describe in terms of the original variables. Another reason is to explicit symmetries or special properties of integrand or region of integration. By changing the order of integration, you may uncover symmetries or patterns that make the integration process more efficient. Visual representation of the region of integration. Visualizing a region of integration is crucial for understanding the necessity of changing the order of integration. Let us consider a double integral an example. For example, f of x comma y over the region R in the xy plane. Suppose R is defined by the inequalities a less than or equal to x less than or equal to b and g1 of x less than or equal to y less than or equal to g2 of x, where g1 of x and g2 of x are functions of x. Then to visualize R, you can plot the curves y equal to g1 of x and y equal to g2 of x. Then in x1 xy plane, the shade and the region bounded by the curves x equal to a and x equal to b. Derivation formula for changing the order of integration. To derive the formula for changing the order of integration is, let us consider a region R in the xy plane, double integral R f of x comma y dA, where f of x comma y is a integrand and dA represents the area element. Suppose R is defined by the inequalities a less than or equal to x less than or equal to b and g1 of x less than or equal to y less than or equal to g2 of x, where g1 of x and g2 of x are continuous functions of x. Then the integral can be expressed as integral a to b integral g1 of x to g2 of x f of x comma y into dy dx. After changing the integral becomes integral c to d integral h1y to h2y f of x comma y dx dy. Applications of change of order of integration in solving integrals. Changing the order of integration is a powerful technique that finds application in various areas. For example, solving double and triple integrals. Changing the order of integration often simplifies the evaluation of double and triple integrals. By rearranging the order, we initially difficult or impossible to solve. This is particularly useful in cases where the integrand or the region of integration exhibits certain symmetries or special properties. Region transformation. In some cases, changing the order of integration allows for a natural description of the region of integration. This transformation can be especially helpful when dealing with irregular or complex regions. Applications in probability and statistics. In probability theory and statistics, changing the order of integration is often used to compute joint probability distributions, expected values and movements. Applications in physics and engineering. In various fields of physics and engineering, integral arises the context for solving problems related to electromagnetism, fluid mechanics, heat transfer and quantum mechanics. Applications of Fourier's and Laplace transforms. Changing the order of integration is employed in the evaluation of Fourier and Laplace transforms, which play fundamental roles in signal processing, control theory, and differential equations. Volume and surface area calculations. Changing the order of integration is useful for computing volumes of solids and surface areas. Common mistakes to avoid when the changing the order of integration. When we changing the order of integration, there are several common mistakes to avoid. First one, incorrectly identifying the region of integration. It is crucially to accurately identify the understand the region of integration in both original and transformed orders. Mistakes in defining the region and lead to error setting up new integral. Second one, neglecting to update the limits of integration. When changing the order of integration, it is essential to update the limits of integration accordingly. Failing to failing to uh, failing to do so can result in integral equations. Violating inequalities. Ensure that the inequalities used to define the region of integration are correctly preserved when changing the order of integration. Incorrectly setting up the new integral. When switching the order of integration, it is important to correctly set up the new integral based on the updated limits. Forgetting to change the order of integration in iterated integrals. If you are working with iterated integrals, ensure that you change the order of integration in both inner and outer integrals. Skipping the sketch of the region of the integrals. It is helpful to sketch the region of integration before and after changing the order of integration. Rounding errors. Be mindful of rounding errors, especially when dealing with numerical computations. The change of integrals rounding too early or inaccurately can affect the results. By avoiding the common mistakes and carefully following the steps, we can changing the order of integration easily. Thank you.